Hi, this is Mr. Miller and welcome to video 2B. We're going to talk about finite intervals and introduce what's known as interval notation. Okay, we're going to start describing a little bit different graph than what we're used to. So if I look at this graph, I have numbers that are in between -2 and 4. This graph doesn't kind of continue on like our previous graphs did. That's why it's called a finite graph or a finite interval, because it's bounded between two numbers. Okay, so it said describe the set of numbers graphed above, so we can describe it two ways. Numbers that are in between -2 and 4 and include -2. That's one way of describing it. Another way of describing it, it says, would be to say values of x that are greater than or equal to -2, but less than 4. All right, so I'm going to use that last one to write an inequality for this. This is actually a combination of two inequalities. This set of numbers right here, these are the numbers that are greater than or equal to -2, but also less than 4. See, I have two inequality symbols to kind of express that fact. I kind of like this notation because it looks like x is in between -2 and 4. And sure enough, the numbers we have are in between -2 and 4. When you're writing this inequality notation, the direction of the inequalities will always be like this. We go from smaller to larger. -2 is less than or equal to our number, is less than our 4. The only thing that's going to differ from problem to problem is whether we put the equal sign under the inequality or not. And that, of course, depends on whether the dots are solid or open. Okay, so that's inequality notation. Interval notation is kind of a shorthand to represent a range of values like this. Okay, well, for interval notation, we just record the endpoints, -2 and 4. And we're either going to put square brackets or open parentheses around them. So in this case, we're going to use a square bracket around -2. It turns out that that means that this interval includes -2. Square brackets go with solid dots. All right, to show that this interval goes up to 4 but that doesn't include 4, we're going to use a parenthesis, a curved parenthesis like that. All right, so parentheses go with hollow dots. So let's make a little note to ourselves. A solid dot, that goes with a square bracket, and a hollow dot goes with a curved parentheses. Okay, so let's see another example of this. So in this problem, we have values that are in between 3 and 9, but they don't include 3 and 9. Or another way of saying this is that our numbers are greater than 3 but less than 9. So let's write the inequality. So x is greater than 3, but less than 9. So again, notice I go from smaller to larger. 3 is less than our number, is less than 9. Well, for interval notation, we just write the endpoints, and we have to decide whether we're going to use curved parentheses or square brackets. And it turns out, since these are hollow dots, we're going to use square parentheses. So this means all numbers in between 3 and 9, but not including 3 and 9. Okay, so in these examples, we're going to practice writing, describing the interval in inequality notation and interval notation. So these are solid dots, so we have numbers that are greater than or equal to 2, that's the left endpoint here, or less than or equal to 11. That's the right endpoint. Okay. In the interval notation, those are the endpoints. We're going to use square brackets because it includes both intervals. All right, this one. All right, our numbers x are greater than -3, but less than or equal to 5. All right, in the interval notation, we're going to write -3 and 5. -3 gets a curved parentheses, while 5 gets a square bracket. Okay, let's try these. And after you practice this a little bit, this is not going to be a problem at all for you. So we have x is greater than 7 for this one. And on the right, we see that it's less than or equal to 10. So 7 and 10 are the endpoints. This one curved, this one square. Right? This one is the numbers in between -5 and 1, including -5 and 1. So x is greater than or equal to -5, less than or equal to 1. So -5 and 1 are the endpoints, and they get square brackets. All right, this is our last slide with some examples. It says draw graphs for the following intervals. Okay, well, let's read this. So starting with x, it's greater than or equal to -2 and less than or equal to 4. It's in between these two numbers and includes those numbers. So I'm going to put a solid dot at -2, and a solid dot at 4, and I'm going to connect them. And that would be my graph. By the way, in interval notation, this would just say -2, 4 with square brackets. All right. Focus on x. X is between -7 and 1, and it doesn't include them. So hollow dot at -7 and 1, and connect them. All right. In interval notation, this would be -7 and 1 with curved parentheses. All right. This is supposed to be, I think, a square bracket here. So I'm going to treat that like a square bracket. So we have numbers that go from -3 to 7 and include -3. So this is -3, hollow dot is 7, and let's connect them. All right, now they gave us interval notation, but if we wrote this as an inequality, it'd be x is greater than or equal to -3 and less than 7. All right, last one. We have this is interval notation. We have an interval that goes from -1 to 6. So hollow dots at -1 and 6, and connect them. And this would be x is greater than -1 and less than 6. So our goal for you, after a little bit of practice, is to be able to go in between a graph, an inequality, and an interval notation. All right, good luck.